So ask other people to join quickly. Time is 9:30. So today is model 2. So before that, so I have given assignment 1 in the Google Classroom. Some two more questions and two big questions. You have to solve it and you have to submit before this Friday. Okay. If you have any doubt, you can ask me. You message me. I will guide you. So you have to complete the assignment before this Friday. So you see the questions, write it down in a paper, take a photo, and upload it in the Google Classroom. So I will verify it and assign marks in the Google Classroom itself. Don't copy. So copy means don't make a. You can write it on your own. So if you have any doubts, you can ask your friends. So don't make it copy. Okay. So you have to complete the assignment before this Friday. So your assignment 1 has 5 marks. For late submission, I will reduce the mark. So if you submit late, I will reduce the mark. So I will put marks, but I will reduce marks due to late submission. So this is today we are going to model 2. So in the model 2, we have two parts. One it is electrical machines, another one is electronic devices. So in the electrical machines, you have DC machines as well as AC machines. So first we are seeing DC machines. Next we go to see AC machines. So in electrical point of view, what is a machine means? So it will convert the electrical energy in one form to another form. So for example, transformer means it will boost the voltage. It will boost the low voltage to high voltage or high voltage to low voltage. So if it is a generator or motor, it will convert the mechanical energy or it will produce the mechanical energy. So in DC machines, you have two main components. One it is motor, another one is generator. So motor means you have to give the electrical input, electrical energy. So it converts the electrical energy into mechanical energy. For generator, it will generator you have to give mechanical energy as input, and some electromagnet or permanent magnet will be there. So it will produce electrical energy. So the input is mechanical energy, the output is electrical energy for generators. So these are main components in DC machines. So in the DC machine, you have only two parts. One it is motor, another one is generator. Even though it is two different machines, the construction wise both are same only. So if you give electrical energy, it will produce mechanical energy. If you give mechanical energy, it will produce electrical energy. So the construction wise, the DC generator or DC motor is similar. So you should understand that DC motor and DC generator construction wise similar. So depending upon the input you are giving, it will act as a motor or generator. If you give mechanical energy, it will act as a generator. If you give electrical energy, it will act as a motor. Okay. So in this diagram, so I have three IDs. So we look at in my name. I have three IDs. So in one ID only I have the presentation. So other IDs I have only photos. My photo will be there. So you go to the corresponding PPT. Out of three ID, one ID only having the PPT. You go to the corresponding ID and pin that. Only the PPT is visible. I hope everyone is viewing the PPT. So this is the construction of the DC machines. As I already told that DC motor and DC generator construction is same. So this is a starter. The starter is used only for motor. If it is a generator, it is not used. Okay. So here there is a cooling fan. So in the inner part, you have two main components. One it is stator, another one is rotor. Rotor means rotatory motion. The component which rotates is called rotor. The component which is stationary is called stator. Okay. The component which is rotating is called rotor. Component which is stationary is called stator. Okay. So this is a basic conception we see in depth. Okay. So what is the principle we are using in this motor and generator? So this Maxwell corkscrew rule indicates the direction of the current produced. So if I am giving a mechanical input as a mechanical power as input. So mechanical energy is a rotational energy. So it may be a linear energy. So in this case, it is rotational energy. So it has a direction also. So it has clockwise direction or anti-clockwise direction. So in this Maxwell corkscrew, so here they are given a direction. So it is a anti-clockwise direction. This figure, if you see, it is a anti-clockwise direction. So if you screw in an anti-clockwise direction, the direction of the current produced will be downwards. If you unscrew, doing a clockwise direction, current direction will be upwards. Okay. So this is the rule which is developed by Maxwell. So it depends upon the corkscrew. So they are given the name Maxwell corkscrew rule. So you have to hold the corkscrew in your right hand and rotate in a clockwise direction. So the current will advance in the direction of the current. So the direction in which the hand rotates will be the direction of the magnetic lines of the force. So I am holding the corkscrew in the right hand. So I am rotating the clockwise. So I am rotating the screw in clockwise means it will go depth. So it will move inside. Okay. So it will move inside. So I may unscrew means it is anti-clockwise. So whenever you screw any screw, you make it screwing means you are doing clockwise operation only. So if you are making clockwise operation, so the screw will enter into the corresponding location. Okay. So you are holding the corkscrew in the right hand and rotating in the clockwise direction. So the screw will advance in the direction of the current. Okay. It will go inside the required location. Okay. So the direction in which the hand rotates. If you unscrew means it will come outside. Okay. So the direction of the rotation of the hand will indicate the direction of the rotation of the magnetic lines of force. So this Maxwell corkscrew rule is applied to generator. So the mechanical power applied is maybe clockwise direction or anti-clockwise direction. So depending upon the clockwise direction, the current produced direction will be in one side. If we change the direction, the current produced in the direction will be other side. So next one is Fleming left-hand rule. So this principle is used in motors. Okay. So you take the three hands, you take the left hand, take three fingers. Okay. So the middle finger, so this is known as the middle finger, this finger indicates the magnetic field. So this finger indicates the magnetic field. That field is called stator field. So in a motor, there is no permanent magnet. So it is only electromagnet. So we are giving only DC supply. So when you are giving DC supply, the stator becomes electromagnet, and it will produce the magnetic lines of force. So this is the direction of the magnetic field of the stator. So in the rotor also you are giving DC current. So this is the current direction in the rotor. Okay. So when these both interact, the motor will rotate in the clockwise direction. Okay. If the current coming from this end to this end, the motor rotates in the clockwise direction. If the direction of the current is reversed, for example, I am moving from inward to outwards. If it is outwards to inward mean the motor direction will be anti-clockwise. Okay. So depending upon the direction of the current of the rotor, the motor rotates in clockwise or anti-clockwise direction. Okay. The magnetic field lines is constant. So you are giving a DC current, the stator magnetic field direction is always constant. The direction of the current induced in the rotor is depending upon the supply you are giving. So for rotor you have two ends. Say I am taking R1 and R2. So if I give R1 plus and R2 minus means the motor will rotate in a particular direction. So if I change plus and minus to R2 and R1 means the motor rotates in the opposite direction. Okay. So depending upon the DC current you are giving to the rotor, the motor rotates in the particular direction. So if you change the plus and minus in the rotor field, automatically the motor rotation direction will change. Okay. This is an interview question. Let me, we change the direction of current of the rotor, what will happen? So you have to mention that. So the direction of rotation of the motor will change. So this is the explanation for the Fleming's left-hand rule. So it is used to determine the force acting on the current carrying conductor. The rotor only rotates. Okay. So stator magnetic field is constant. So rotor magnetic field produces another flux. This flux is interact with the stator flux, and force will be acting on the rotor, and the rotor will start to rotate. So middle finger, thumb, you know, middle finger is third finger, forefinger is second finger. Of the left hand are kept at right angles to one another. So middle finger represents the direction of the current. So if it is very important. So if you change the direction of the current, automatically the rotation direction also changes. The forefinger represents the direction of the magnetic field. Thumb will indicate the direction of the force acting on the conductor. So force acting on the conductor means whether it is rotate clockwise or anti-clockwise. This rule is used in motors. Okay. Next one is Fleming's right-hand rule. So in this Fleming's right-hand rule is applied to generator. Okay. So here also in the stator you are giving a DC current. So it will produce a magnetic field. So you are giving mechanical input, whether it is a clockwise rotation or anti-clockwise rotation. So depending on the direction of the rotation of the mechanical power input, the induced current direction also changes. Okay. So here see. So a Fleming's right-hand rule is used to determine the EMF induced in a conductor. So the middle finger, forefinger and thumb of right hand, it is not a left hand, it is right hand, kept at right angles. The forefinger represents the direction of the magnetic field. The thumb represents the direction of the motion of the conductor. Okay. So when the direction of the thumb, for example, when you give mechanical input, clockwise rotation means the current direction in one direction. So if we change the rotation of the mechanical power, the current direction will be opposite to the previous. Okay. The middle finger will indicate the direction of the induced EMF. This rule is used in DC generators. Next one is Lenz's law. So what is Lenz's law is, so whenever there is a coil, here you are giving a current. Okay. So when the current is flowing through a coil, so it will produce a flux. So this flux will create an EMF that is known as induced EMF. So how we can determine the induced EMF? This is found out by Lenz. Okay. So the Lenz law indicates the direction of the induced EMF and how much EMF is induced in the particular coil. Okay. So Lenz law indicates the direction of EMF as well as the EMF induced. So the EMF induced will be opposite to the current flowing through the coil. So there is a coil. So you are supplying a current. So due to this current, a flux will be induced in the coil. This flux will oppose this flux will produce an EMF. This EMF will oppose the input EMF. So you are giving a voltage that this induced EMF will oppose the input voltage. So this is known as Lenz's law. So the induced EMF value will be less than the applied voltage. So the E equal to minus N. This minus indicates that it is opposite to the applied voltage. It is not negative one, it is opposite to the applied voltage. That is why we are putting minus here. So minus N. N means number of turns. d by dt is rate of change of flux. Phi means flux. d by dt, it indicates that rate of change of flux with respect to time. Okay. Lenz's law will indicate two things. One, it will indicate the direction of the induced EMF. Second one, it will indicate the amount of induced EMF produced in a coil. The formula for induced EMF E equal to minus N d by dt. Okay. So we have seen only about what are the laws. So there are two types of DC machines, motor and generator. So what is motor? So it will convert mechanical energy, electrical energy to mechanical energy. So in input is mechanical energy, output is electrical energy. So generator means input is electrical energy, output is mechanical energy. Next we have seen the three laws. So first one is left hand rule, right hand rule, and another one is Lenz's law. So Lenz's law indicates that the induced EMF in a coil will oppose the applied voltage. The equation for this is E equal to minus N d by dt. Fleming's left hand rule is used in motors. So the direction of the current in the rotor will determine the rotation of the motor. In generator, the direction of the rotation of the mechanical power input will determine the direction of the induced current. So it is used in generators. So we have seen only the roots. So next we go to see what is DC generator. So this is the first topic. So in the first topic, so first machine is DC generator. So as I already mentioned that DC generator will convert mechanical energy into electrical energy. It will convert mechanical energy into electrical energy. So there are three essential requirements for a DC generator. You require conductors. So what is conductor means? So in our machine it is rotor. So rotor is the conducting material. So next one is magnetic field. So the magnetic field is produced by the mechanical energy. Magnetic field is produced by the current we are supplying in the stationary part. Next one is mechanical energy. So we have to move the rotor by using a rotor of a generator by using a mechanical power. So normally the mechanical power in olden days they have rotated by humans. The humans will rotate the wheel. So just they producing electrical energy. Nowadays instead of using humans, they are using another motor as prime mover for the generator. So the mechanical energy is produced by a prime mover. We are calling as a prime mover, even though it is a motor. So when connected to a generator, we are calling as a prime mover. So the magnetic field is produced by the stationary part, stator. So the conductors are the rotors. The generators, rotors, initially it has no voltage. It is only a coil. It is rotated by a prime mover. So there is a magnetic field. This coil will cut the magnetic field due to the rotation of the prime mover. Okay. So this is the arrangement of the DC generator. So north pole, south pole. These are stationary parts, stator. So the magnetic lines is flowing. So this conductor is the rotor. It is rotated by the prime mover mechanically. Okay. So when it rotates, it will cut the magnetic lines of force, flux. So due to this, an EMF is induced in the coil. Okay. That EMF is taken out as the generator voltage. So generator works on the principle of Faraday's law of electromagnetic induction. So what is Faraday's law of electromagnetic induction? So whenever a coil cuts a magnetic field, an EMF is induced in the coil. So this is known as Faraday's law of electromagnetic induction. So whenever a coil cuts a magnetic field, an EMF is induced in the coil. So here the conductor is the rotor. It is continuously moved by the prime mover. So when the conductor is moved in the magnetic field, an EMF is induced, and the magnitude of the induced EMF is directly proportional to the rate of change of flux linkage. Okay, so there is a constant magnetic field which is produced by the stator. You are moving the rotor continuously by a prime mover. So the conductor is continuously rotating inside the magnetic field. So it is continuously cutting the magnetic field. So the rate of change of flux linkage means how it cuts the flux. Flux linkage means the flux which is linking with the rotor. The rate of change is during the rotation. The flux linkage is not constant. So for a particular time it is maximum. Sometimes it is very low. Sometimes it is medium. So we are calling as a rate of change of flux linkage. So if it is constant, we say tell it is change of flux linkage. Since it is not constant, we are using the term rate of change of flux linkage. So we are moving the rotor inside the magnetic field, and EMF will be induced in the rotor. So the rotor, it is directly proportional to the how far it is cutting the flux. This EMF will cause a current flow. So the rotor is short circuited means, so this EMF will be converted into current. Okay. So EMF is induced in the coil. If you make it a closed connection, it is a short connection, this voltage will automatically converts into current. Okay. So this is the construction of a DC machine. So the cross-sectional view of a DC machine. So in this machine, if you see, this is stator frame. So any machine requires a outer cover. That is known as stator frame and yoke. This is for only for mechanical support, and in order to prevent the machine from moisture, dust, shock, and etc. So it is only a mechanical connection. The stator frame and yoke. So another one is known as field winding. Okay, field winding is the stationary one, stator. So it only produces the magnetic field. Okay, so we are calling as a field winding. Next part you see a rotor. So this part is known as rotor. So we are calling as a armature core. So in DC machines, we are calling the rotor as armature and stator as field winding. Field means it is stator, armature means it is rotor. So this armature core is also a rigid one because it also have some coils. For mechanical support, this it is make it as a rigid one. Okay, there is a soft available here. The soft, because I have already told that generator as well as motor construction is same. So this soft is connected to the prime mover. In case of a generator, in case of a motor, if we want to connect a load means you can use this soft. Okay. So next one is commutator. So what is commutator? So commutator is one of the important device in DC machines. So it will convert the AC into DC. Okay. In a generator, in a DC generator, the EMF induced in the coil is not a constant one because the rate of change of flux linkage is varying. So the EMF induced is also varying. So it is not a constant one. So in order to make that varying voltage into a constant voltage, we are using the commutator. The commutator will convert the alternating voltage into direct voltage. So it will move all the positive and negative values of the AC voltage into one side. So even though it is DC voltage, it is not a constant DC voltage. It is only a pulsating DC voltage only in a DC generator. Okay. So in the generating stations, after power generation, it will be stabilized only, then it will be supplied to the transmission lines. Okay. So it is all the generators will be connected to a bus bar. So all generator voltages are making constant only, then it will be supplied to the bus lines. Okay. So DC voltage is of two types. So whether it is a constant DC voltage or a pulsating DC voltage. So I have no INSPIRE software here. So constant DC voltage means 5 volt means it is 5 volt only, positive 5 volt. So in pulsating DC voltage means the voltage is positive only, but it is varying from 4 to 5 volts, 4 volts, 4.5 volts, 3 with 3.5 volts, 4 volts, 4.2 volts. So it is varying. So we are calling as a pulsating DC voltage. If you have positive values and negative values, we are saying that it is a alternating voltage. It alternates between positive and negative values. So DC voltage means direct current, direct voltage. So it means it is in one side, positive side. So plus 1 volt. Even though it is varies from 1 to 1.5 volt, we are saying it is a DC voltage. Okay. So this commutator will convert the AC voltage generated in the machine into DC voltage. The purpose of this commutator is that one. Next one is brush. So the brush is made up of carbon. The brush is used to connect the external AC voltage. So we have to give voltage to the machine. So the brush only connecting that voltage to the machine. That is the purpose of the brush. Next one is what is a sectional view inside a DC machine. Okay. So this is a view. We are seeing a view of a DC machine. So this field N, S, N and S, these big poles. So this is the stator. So it is not two coils. This it may be four poles. We are saying that it is a pole. So north pole, south pole. Here there are two north pole and south poles. Some machines have 4 poles. Some machines have 8 poles. Some have only 2 poles. Some have 16 poles also. So depending upon the magnetic field strength you require, you have to fix the number of poles. So the magnetic field is divided into number of poles, and the coils are connected. The coil is connected to the stator coils. We are mentioning that as a field coils. Okay. Next one, here there are some small poles, which is called interpole. So what is the use of interpole? So the magnetic field strength is not enough, means we can use this interpole and we can increase the magnetic field strength here. That is the purpose of the interpole. These interpole are small in size. This will increase the magnetic field strength of the inside the machine. Okay. So next one you see, this is pole soup. This line is known as pole soup. Next one, the winding which is connected in the pole is called field winding. So we are calling as a sun pole. Since it is a sun machine, we are calling a sun pole. But series machine, we call it as a series pole. Okay. Next one is armature. Here you see a round part which is called armature. So in the armature also you have a large number of coils. So this coil is known as armature coils. So this armature we are calling as a rotor. So these coils are called as conductors. So if you see every coil is called as a conductor. So the outer body is called frame, the machine frame. So inside the armature you have another circle. So this part is known as commutator. As I have already mentioned, the purpose of the commutator is to convert the AC to DC. The purpose of commutator is used to convert AC to DC. Okay. So in the field winding, we are giving DC supply. So in the armature winding also, so we are giving DC supply for motor, and we take DC supply outside in for a generator. So this commutator is connected to brushes. The brush only supply the brush only supply the required current. Okay. So this is a cross-sectional view of a DC machine. This is same for the generator as well as the motor. So as I have mentioned, this is the outer frame. This is poles. The outer frame we are calling as yoke. So this is armature. So in the armature you have slot. The inside the slot you have conductors. So conductors are coils. Okay, conductors in slots. So inside the armature you have a commutator. So the commutator is connected to the brushes. Okay. So this is the field winding. So how the real machine will be? Field winding will be like this only. So this is rotor and rotor winding. So it is a rigid one as I already told. So this is rotor winding. So inside the rotor you have commutators. This is commutator bars. Okay. This is the working principle of DC motor. So we have seen DC generator, next DC motor. So north and south pole will produce a magnetic field. This armature also we are giving a current. So this will produce another magnetic field. So already one magnetic field is there between north and south pole created by the stator. So another magnetic field is produced by this coil. So two magnetic fields are there in the inside the machine. These two magnetic fields will interact and it will cause the rotor to rotate in a particular direction. So depending upon the direction of the current supplied. So if you change the direction of the current, so first if it is rotating in clockwise direction, now it will turn into anti-clockwise direction. Okay. So when electric current is passed through the coil, when electric current is passed through the coil in a magnetic field, magnetic force produces a torque which starts a DC motor. I am supplying a electric current in the stator, so it will create a magnetic field. I am supplying another current in the rotor, so this will create another magnetic field. These two magnetic field will interact. So if I supply from this end, it will make the rotor to rotate in the clockwise direction. So if I supply the current in this direction, it will make the current to rotate in the anti-clockwise direction. So what is the working principle of a DC motor? So this is north pole and south pole. This magnetic field is constant. So we are giving a DC voltage through the brush. So split rings. So commutator, inside the commutator it goes to the armature. The current direction is from A, B, C, D. So this magnetic field and this magnetic field will interact and this will make the rotor to rotate in the clockwise direction. This one leave it. So in the winding, so armature winding, there are two types of winding you can construct. Okay. So first one is lap winding. So another one is wave winding. So before go to this topic, sir will ask one questions. Gautam sir.
Yes, sir. Naveen. Naveen, are you there? 112, Naveen. Naveen, are you there?
Naveen absent Budlama. Naveen G.
You won't respond in a chat box itself. You won't respond in the chat boxes also. Sir, we can
Naveen
put
G. 19A112 absent. Even though you are right here, since you are not responding, you are absent.
Yuvraj. 118 Yuvraj.
Sir.
Okay, Thambi, what is meant by commutator? What is meant by commutator? What is the purpose we are using the commutator for?
Sir, it reverses the current direction, sir.
Wrong. Good answer is wrong.
It
So it
converts
will.
மாதிரி தான் உங்களுக்கு ஸ்டார்ட் ஆகும். It convertsங்கிற மாதிரி தான் உங்களுக்கு ஸ்டார்ட் ஆகும் ஈக்குவேஷன், ஐ மீன் டெஃபினிஷன்.
Sir, from DC to AC it comes. Comes from DC to AC.
நாங்க ஃபர்ஸ்ட் லெட்டர் எடுத்து விட்டா நீங்க கம்ப்ளீட் பண்ணிருங்க, அப்படிதான் தம்பி? Yeah, okay, it is correct. It is going to convert the DC to AC. Okay. Okay, Raj. Next, Aswath, 101. Aswath. Aswath, 101, are you there? Aswath.
Aswath, எங்க இருக்கீங்க? Aswath, respond.
Ashwath, just a minute, sir. HOD Automobile Engineering. Hello. Hello. Sir, HOD Automobile Engineering speaking.
Yes, sir.
Just a minute. Ashwath. Ashwath, line la irkiya ba? Hello. Hello. Ashwath. So marking as option, sir. Okay. Okay, please continue, sir.
Okay.
Okay, sir. Okay, sir. I will make answer.
Sir, I will start the session. So we have.
Yeah, okay, sir.
We
Okay,
see the construction. So from the construction, we understand that. So you have a yoke for mechanical production. You have a field winding. It may have more number. It may be have 2 poles or 4 poles or 8 poles or 16 poles. So these poles only produce the magnetic field. So in order to increase the magnetic field, we are using interpoles. There is a armature. In this armature, you have number of slots. So inside the slots, you are placing the conductors. These conductors we are calling as armature coils. Okay. So inside the armature, you have commutator. The purpose of commutator is used to convert the AC to DC in case of generator and DC to AC in case of motor. It will do 2 purpose. If it is a motor, it will convert DC to AC. If it is a generator, it will convert AC to DC. You should understand that. So it is a purpose, commutator has 2 purposes depending upon the type of machine. The brush is used to carry the current only. So these are actual machine, how is the actual machine will be. So if you have electrical machine slab, we will show in the machine slab, but it is not possible. So I am showing in the slides. So this is working principle. So next we go to the winding. So we have some problems in this DC generators and motors, sums. So you have to know this, what is lap winding, what is wave winding, and we have how the EMF is generated, how much EMF is generated in a DC machine. So what is the speed? You have to calculate this. This type of problems you have to calculate in this model. So this model has both theory part as well as problem. So you have one theory question and one problem question. So like this only this model will go. DC machines, electrical machines unit. Okay. So next one is armature winding. So we see armature winding. So this armature winding you can construct by 2 types of winding, either lap winding or wave winding. Okay. So lap winding is equal. So you have to construct the lap winding such that A equal to P. What is A? So A is number of parallel paths. So parallel paths. So I have connecting coils. So how many parallel coils I am connecting? That is known as number of parallel paths. That is known as A. P indicates number of poles. We have already seen the poles. So that is P. So the number of poles is 4 means you have to give number of parallel paths equal to 4. The number of poles is 8 means you have to give the number of parallel paths equal to 8. That is known as A equal to P. So the armature windings are divided into number of seconds equal to the number of poles. Next one is wave winding. So here the number of parallel paths is fixed, only 2, A equal to 2. So this type of winding is used only in low current output. If you want a low current the output means you have to give this winding, wave winding, and a high voltage also produced. So in the wave winding you require 2 brushes also. So field system. So here there is no permanent magnet, so it is only electromagnet. So even though it is electromagnet, we are supplying DC current. Since it is DC current, the magnetic field is constant. So it is produce a uniform magnetic field. The armature will rotate. The electromagnets are preferred when compared to permanent magnet. Why means, so electromagnets are cheap. Size is also smaller. So greater magnetic effect also. If there is any reduction in magnetic field, we can introduce interpoles, or we can change the coil also. You can easily vary the field strength. But in electromagnet, you cannot change the field strength. It is fixed only. So if it is giving an electromagnet means you can change the current so that you can change the magnetic field strength also. Okay. Since there are large number of advantages in electromagnet, so we are using electromagnet in DC motors and generators. So in the first we are seeing field system. The field system, we have already seen what is yoke. It is the outer cover, which gives mechanical protection. So it prevents the machine from dust, moisture, and other mechanical failures. So pole cores, this is the pole connections, that is known as pole cores. And pole shoes, the end of the pole we are calling as pole shoes. Field coils is, it is connected to the poles. The coils which is connected to the poles are called field coils. So in the armature core, we see that in the diagram it is a cylindrical one. It has high permeability silicon steel stampings. So why we are using stampings means for insulation purpose only. Then impregnated, it is prevent from moisture. So lamination is used to reduce the eddy current losses. Okay. So high permeability means it will produce more flux also. So it is prevent from moisture. So lamination is used to reduce the eddy current loss. If there is no lamination, means the eddy current loss will be very more in DC machines. So another part is commutator. So it is used for connecting the DC machine with the external circuit. So it will convert the AC into DC. Unidirectional means it is DC. Unidirectional, one direction. Uni means one directional current in generator. It is also a cylindrical shape. We have seen that. So it is made up of small copper segments. That copper segments are used in commutators. These segments are insulated from one segment to another segment. So it is connected to the armature conductors by a copper strip called riser. So the number of segments in the commutator is equal to the number of coils in the armature. So this is about commutators. Next one is brush. Normally it is used of carbon brush. Copper brush, there are some more brushes also there. Mostly 90% carbon brushes are used. Carbon brushes are used in DC machines because they are very soft materials. So it will not generate spikes. So during connection, so this commutator is rotating. The carbon brush only taking the current or supplying the current. So while touching, the arc will rises. So these carbon brushes will not generate high spikes when compared to other brushes. It is only supplying the current to the armature or receiving the current from the armature. So the carbon is used for brushes because it has negative temperature coefficient of resistance. What is negative temperature coefficient of resistance means? The temperature is rises means the resistance will decrease. For example, if you have positive temperature coefficient of resistance means the current is increasing means the resistance will also increase. So the brushes itself cause more voltage drop and there is no useful voltage at the receiving end. So it is a carbon has a negative temperature coefficient of resistance. So it is mainly used. This is a self lubricating one. So it can easily change its shape. So it will change its shape and it will increase the area of contact. The carbon is flexible when compared to other brushes. If it is a metal brush, so it is not flexible. It will not change its shape. Okay. Carbon has the property of changing its shape. So it has a negative temperature coefficient of resistance. It can change the shape. It will not produce spikes. So this, due to these advantages, 90% of DC machines are made up of carbon. So this is the arrangement of a brush rock and a holder. So what is inside here? Carbon brush. Brush leads, brush rocker, front end cover, rear end cover, cooling fan, bearing and internal box. Next one is very important. So we have seen the construction details of a DC machine. For DC motor, you have to write the same thing. DC generator, you have to write the same thing because construction wise both are same only. Working principle is different. Construction is same only. Okay. Next, we are going to find the EMF equation of a DC machine. So, first, before we are going to derive that, we want to know some terminologies. So, pi is the flux. We know it is flux. So, here it is flux per pole. Since there are more number of poles, we have to take the pi as flux per single pole. The flux unit is Weber. So it is flux per pole in Weber. Z means total number of conductors. So this is total number of conductors in the armature. So we are representing the conductors as Z. P, I have already told that it is number of poles. A, I have already told that it is number of parallel paths. Next one is N. N is armature speed in RPM. N is armature speed in RPM. So EG, EMF generated in one of the parallel paths. Any one of the parallel paths. If it is a 6 parallel path, first finding any one of the parallel path, then we multiply by the required parallel. For these 6 terminologies, you should know before deriving the EMF equation of DC generator. Pi, flux per pole, Z, total number of conductors, armature conductors, P, number of poles, A, number of parallel paths, N, armature speed in RPM, EG is the EMF generated in any of the parallel paths. Okay. Now, we are taking a single conductor and a single revolution. So a flux is cut by a conductor in one revolution. Okay, that is equal to, so flux is equal to flux per pole, P into pi. Pi is flux. So pole into flux. Next, flux cut by the conductor in 60 seconds. Then you have to multiply the poles into flux per pole pi into N. N is the speed. For 60 seconds, we are dividing by 60. Okay. So N is the speed in RPM, revolution per minute. Revolution per, so we have told that revolution per minute. So this is flux conductor in 60 seconds equal to V by Zn by 60. Next one is average EMF generated in one conductor. So this is for one flux. This is flux. Pi, P is the number of poles. Pi is the flux. Pi is flux per pole. So you have to multiply with the number of poles. Then only you get the total flux. So that is the total flux cut by the conductor, single conductor. That is P into pi. Next we are taking the flux cut by the conductor in 60 seconds. So you are multiplying by N by 60. So N is the speed. So N by 60, you get the P pi N by 60. So this is the EMF generated in the single conductor. So pi N P by 60. Pi NP by 60 is the average EMF generated in a one conductor. Okay. For every parallel path, there are number of conductors. So how to find this number of conductors? So you have to divide the number of conductors by parallel. So Z by A. Okay. Then you have to multiply with this average EMF. EG equal to PZ by, we already found that P pi N by 60. You have to multiply it by Z by A. So it becomes PZ pi N by 60 A. Next we are making that EG equal to Kn pi N. So why we are making that means, so Kn is a constant. So whatever constant we are taking as a P is a constant. Number of ports will not change. Number of conductors will not change. Number of parallel paths will not change. 60 will not change. So all these constant terms we are taking out as a single constant. That is known as Kn. Pz by 60A. That is Kn, we are substituting Kn. Eg equal to Kn pi N. So flux will change, N also change. So when you are writing deriving the EMF equation, you have to write Kg equal to, so I am using pi first, pi Zn by 60 into P by A. Okay. There are some problems we see in the afternoon. So whenever you do problems, when you are asking for EMF generated in a DC generator, Eg equal to pi Zn pi Zn by 60 into P by A. Okay. Next, what are the types of DC generator? For DC generator, there are two types. Mainly it is classified into two types depending upon the input method. So how we are giving the DC supply. So one is prime mover, mechanical energy for rotor. Another one is DC supply. So how we are giving the DC supply. So depending upon this input method, we are separating into two types. One is separately excited, another one is self-excited. Next classification is this is about the connection between the field coil and the armature coil. Okay. If the field coil and the armature coil are in series, then it is known as series wound generator. The field coil and the armature coil is in parallel, then we are calling a shunt wound generator. So common wound generator has two field coils. So depending upon these two field coil connections, it may be short shunt and long shunt. The armature is connected in parallel with both field coils, means it is known as long shunt. If it is in between these two, means it is short shunt. Next type of connection is cumulative and differential. So I told that there is two field coils. If two field coils flux are additive, then it is called cumulative compound generator. If two field coils are opposing each other, means it is known as differential compound generator. So if you are asking for classification of DC generator, depending upon the DC supply you are giving, it is mainly classified into types, whether it is separately or self-excited. We separately excited means we are giving the field coil separate. Self-excited means we see the diagram later. Then only it will be understood. Separately excited and self-excited. Okay. So in the connection base, you have three types: series and compound. The compound you have two types: short shunt and long shunt. Similarly, cumulative and differential compound generators. So the characteristics of DC generator. So no load saturation characteristics. So what is no load saturation characteristics? So I'm not connecting any load. So it is called no load. So I'm increasing the field current. So I am not giving the field current constant. I'm increasing the field current. So generated voltage also increases. So it will reach a particular voltage, then it will be saturated. So this graph is called no load saturation characteristics. Next one is internal or total characteristics. So I am giving a load. So what is the graph between the generated voltage and the armature current. But it's a load current that is known as IA. External characteristics is depending upon the load V and I. Voltage and I. So there is an important terminology in DC machines: critical field resistance. So you have to fix the field resistance. So that resistance value should be less than the particular value. The resistance value of the field resistance is higher, then there will be no generation of EMF. So the resistance value should be kept lower than the certain value of resistance. That resistance value is known as critical resistance of the machine. So this is only applicable for field, not in armature. This is not necessary for us. So armature reaction and effects of armature reaction. This is for electrical people. Next we go to the losses. So there are two losses. One is copper loss and next one is iron loss. So copper loss means what? So we are using coils. The coils are made up of copper. So the losses in the copper. So these are called copper loss. So it is occur in shunt coil, field coil. It will occur in armature coil. So there are two copper losses. So when you are varying the current in the field or armature, this copper loss also vary. So we are calling as copper loss or variable losses. Next one is iron loss. So iron loss occurs in the machine. Because the material we are using are iron parts only. Okay. Since we are using iron, the magnetic flux are interacting with that. So there will be a magnetic field will be producing. So even though if you cut off the supply, so it will not come to neutral state. There will be a hysteresis loss and also eddy current loss also there. So this iron loss is constant. The hysteresis loss is always constant. Even though you change the voltage or current, the eddy current loss is also changing. So hysteresis loss depends upon the frequency you are supplying, what is the flux linking with the core, and what is the volume of the. So eddy current loss depends upon the flux density, what is the frequency, and thickness of the lamination. If you increase the thickness of the lamination, eddy current loss will be reduced. Another more losses are there, windage and friction losses. It is also constant. It is due to the opposition of wind and friction. Generally, there are four fixed losses, constant losses: hysteresis losses, eddy current losses, friction losses, and windage losses. These are constant. Okay. The variable losses are copper losses. It will occur in the resistance in the armature winding and field winding. Okay. These are the losses in DC generators. So applications of these DC generators. So shunt generator, series generator, and a common generator. So in the afternoon class, we see the connection, then EMF equation, and we solve some problems in DC generators. Okay. Shunt generator means series connection. That field coil is series with the armature. Stator and rotor are in series. Okay. That is known as series generator. If rotor and stator are in parallel, armature and field are in parallel connection, means it is called shunt generator. So since shunt generator, the voltage is constant. Okay. The voltage across the generator as well as the field or armature are same only. So it is voltage is constant. So since voltage is constant, it is used for battery recharging. It is used as exciters for AC generators, electroplating. Electroplating requires constant voltage. So we are using it for electroplating. So series generator, here the voltage is not constant. So it is boosting the voltage very high. So it is used as boosters, lighting, arc lamp, etc. So this is all about the DC generators. So in the DC generators, first you should know what are the classification. So the construction wise, both generator as well as motor are same. Next, EMF equation. What are the types of DC generators? Separately excited and self-excited. What are the classifications? Series, shunt, and common. Categories: no load saturation categories, internal categories, external categories. What is critical field resistance? So this one not needed. So losses in DC machines. What are the losses occurring in a DC machine? So what are the applications of generators? So next, before going to motors, we have a Q&A session. Gautam sir.
Yes, sir.
Yes.
103 Gokul.
Sir. Sir.
Yeah, what
Sir.
is shunt generator, pa? Are you hear my voice? Yeah, okay.
Sir, yes,
What
sir.
is shunt generator?
Sir, it produces energy.
Yeah, tell me what is shunt generator?
Sir, it produces energy, sir. Energy.
Okay, tell me what is generator?
Sir, that is used when a power cut, sir. It gives
It produces power or
power,
energy?
sir. Power, sir.
Yeah, okay. It makes what
Sir,
conversion? It
Sir,
makes what
electrical energy to
conversion?
mechanical.
Generator is doing electrical to
Sir,
mechanical or
mechanical to
mechanical to
electrical,
electrical?
sir.
Yeah, okay. Generator definition is
Convert
it's converting
mechanical
mechanical energy
energy
into
yes,
electrical
sir.
energy. Okay. Okay. Then what is mean by electrical energy to mechanical energy? What is the term we can tell?
Sir, sir, term and example, sir.
I am telling the definition. Tell me what is
Yes,
that?
sir.
Okay. It is converting electrical energy to mechanical energy. What is the
Engine, sir.
what is the
Engine, sir. DC motors.
engine? Motor definition is
Motor, sir.
converting electrical into mechanical. Okay.
Yes, sir.
Generator definition is it is converting
Converting mechanical to electrical.
mechanical to electrical.
Yes, sir.
Okay. Then
Yes, sir.
okay. Okay, Gokul. Okay. Next one, Prashant.
Sir.
What are the losses you have?
Sir.
Okay, tell me what is movie commutator? What is movie commutator? The last question is I have asked to your friends Ashwath, and for another one I have asked the same question. If you understand the answer, means you surely you can able to tell the answer. What is maybe commutator?
1 minute. Sir.
What is mean by commutator?
It converts to convert DC to AC.
DC to AC. Yeah, okay, okay. Okay, Prashant, okay. Next one. Vishwajit Nayagam.
Yes, sir.
Vishwajit Nayagam. Okay, tell me what is the difference between lap winding and wave winding?
Sir, the lap winding, the armature winding is divided into poles, sir. Equal number of poles.
In lap winding?
In lap winding, the armature winding is divided into equal number of poles, sir.
Okay, super. Next one. For
In
wave winding?
wave winding, it is used in producing the only less power, sir, less current.
Okay, Vishwajit Nayagam. Okay, okay.
So we see what is okay. So
Sir, board is not.
Why it is
Sir, you want to
noisy?
change the position of camera?
Yes, yes. The noise is there. Okay. I have to position camera. Okay.
Yeah, okay, sir. Okay, sir. Now it's okay.
Shall I put a line here?
No, sir. We can able to visible a full board.
Somebody mobile also full board?
Yes, sir. We are seeing the full board, sir.
Okay, thank you. Connecting the Bluetooth, not connected.
Sir, your voice is audible only.
I'm keeping the phone in my hand.
Yeah, okay.
So, first one is series generator.
Sir,
Yeah.
sir, it is a mirror image.
Image.
Yes, sir. Go to desktop and change the mirror image, sir.
அது எப்படி மாத்துறது?
Sir, it is at the right corner.
Right corner. Right corner.
Right corner near next one. Next one, sir. Yeah, that one.
Okay. Now it is visible.
Change the position also.
Hello?
Sir, can you change the image?
Change the?
Sir, now also it is like a mirror image, sir.
Now also mirror image,
Yes, sir.
Now?
Yeah, now it is okay. Okay.
Okay. Thank you. Okay. First one is series generator.
Sir, can you write bigger, sir?
Yes. So series generator has two parts. One it is field. So another one is armature. So armature always you have to put a circle and you have to write A. So these two parts are called brushes. So in the armature you have to write A1, A2. Armature coil 1 and armature coil 2. In series generator, you have to put two armature and field in series. Armature and field in series. Okay. So in series generator, you have to write. So normally it is F1 and F2. Okay. So it is a field coil. The field coil is in series with the armature. Field coil is in series with the armature. So next one is shunt generator. Shunt generator. So in shunt generator, there are two coils as I already told, field coil and armature coil. This is the voltage. If it is a DC motor, we are giving the voltage here. If it is a DC voltage motor, we are supplying the voltage here to the field coil as well as armature. So if it is a generator, so this armature is connected to a prime mover. This is known as prime mover. So this armature will rotate. So here you have to separately give a DC voltage for field coil. So the voltage will be produced in the armature, that is taken back in a DC generator. If it is motor, you have to supply the voltage. If it is a generator, you have to get the voltage. So in the sun generator, so field coil as well as armature are in parallel. Field coil and the armature are in parallel. Okay. So if it is a DC machine, you have to put a line like this. So indicate that DC supply is flowing. Okay. Leave this. So I am taking the way. So if field coil and armature are in parallel. So if it is parallel, we are calling it a shunt. Since it is parallel, both voltage will be same. So as we know that voltage is constant in parallel branches. So it is the voltage will be constant in shunt generators. So next one is COM mode. So common generator has two coils. So I am giving notation like this, S1, S2, S3, S4. These two coils interact each other, and if it is opposes each other means it is known as these two coils flux, two coil flux opposes each other means it is differential compound. Differential compound. Differential compound. If two coil flux additive added each other, then it is cumulative. Okay. So in the common generator, there are two field coil flux. So when the flux interact each other and it will oppose each other and it will cancel and the remaining flux will be interact with the armature. That type of common generator we are calling as differential common generator. If two coil fluxes are added together means it is called cumulative common generator. So the two coils are connected, two field coils are connected with the armature in parallel means it is called long shunt. For example, if it is connected like this means it is called short shunt. So if it is connected here, it is long shunt. If it is connected here, it is called as short shunt. Okay. So these are the connections in series, shunt and common. Series means armature coil as well as field coil both are in series. Both carry the same current. If it is a shunt generator, both are in parallel. Both carry the same voltage. In common, it is different because there are two field coils, maybe differential compound or cumulative compound, whether it is long shunt or short shunt. You have to first determine the values and then you have to find the values. So mostly they will ask problems in series and shunt generators. Okay. These are the connections in series, shunt and common. So we have seen the construction, what are the parts inside the DC machine. So we have know that EMF generator EG equal to 5 Zeton 50 into P by E. Okay. Mostly what they will give means they give all the values except one. So another thing, they will give what is the winding, lap winding or wave winding. So then you have to find the number of parallel paths. The lap winding A equal to what? Wave winding A equal to what? So I will give you a problem. The flux per pole. They will give flux per pole. They will not give the symbol. They will give only in words. Flux per pole is 0.06 Weber. So Z I have already told it is number of conductors. Z is equal to 480. So you have to take the calculator, you have to tell the answer, because I am giving the problem by one. I am not taking the example problem, I am giving by one. So N, so I am taking 1500 RPM. Z is total number of conductors. So I am giving by inverse total number of conductors. Total number of conductors is 480. Speed of the machine is 1500 RPM. 1500 RPM. Flux per pole Z they have given. So then they will give the number of poles. Number of poles is 4. It is a lap winding. Lap winding. Find EMF generator. EMF generator. So this is the problem they have given. So you have to find the EMF generator. They have given the flux per pole 5. Z they have given. N they have given. Number of poles given. They have given a clue that it is lap winding. Then you have to find the EMF generator. For whatever problem you are writing, first you have to write the values. From the problem, you have to write in terms of these letters. Okay? Phi is equal to 0.06 Weber. Next one, total number of conductors, which is equal to Z, which is equal to 480. So you have to write the problem practice that you have to write given data. So from the problem, we have derived that the given data is phi is 0.06 Weber, Z is 480, N equal to 1500 RPM, P equal to 4. They have given lap winding. Since it is lap winding, A is equal to P. A is equal to P, which is equal to 4. Now we have taken all the data from the sum. Then you have to apply in the formula. Eg equal to 5.06. First I am writing the formula by Z10 by 60 into P3. Pi Z10 by 60 into P by. So pi is 0.06, 480, N is 1500, 60, P is 4, A is also 4 by 4. This gets cancelled. No need to multiply and divide. 4 by 4 gets cancelled. Remaining things we have to find out. 6. 0 you can cancel. 6, this becomes 8. Okay. Now, so it is Eg equal to 0.06 into 8 into 1500. So this 0 we can use that. So it is become 6 into 8 into 15. So 48 into 15. 480, 240, 720 volts. Okay. So from the sum, you have to find what is the given data. You have to write all the given data. So sometimes they will give wave winding. Wave winding. Then A is equal to 2. Then you have to put 2 here. So if it is wave winding, so I am changing the formula. First case lap winding, second case wave winding. So this is first case. Case 2. Case 2, A equal to 2. Now EG equal to, here first of all is same only. So 0.06 into 480 into 1500 divided by 50. P is 4, A is 2. This one 720 is into 2,440. Okay. So if it is lap binding, A equal to P. If it is wave binding, A equal to 2. So from this we can analyze that when you are using wave binding, the voltage is higher. Here it is only 720 volts. Here it is 1440 volts. So whenever you use wave winding, the voltage generated in the conductor is high. Okay. Current will be low. Current is low, but voltage will be higher in wave winding. So lap winding means voltage is low, current will be. This is one of the important problems. In this problem, I have given all the data. Only thing I am finding the EG. Sometimes they will give the EG, you have generated EMF, and they will ask for phi, they will ask for flux, sometimes they will ask for the speed, they will ask for the conductors also. They will change, they will give this value EG, they will ask for Z also. Sometimes they will ask for the speed. So any one variable they will ask. So this is the formula you have to understand. You should know that. So one important problem will be there in this question. So in this question, either you have to find the generated EMF, or you have to find the flux, or you have to find the number of conductors, or you have to find the speed and so on. They will ask any one. Remaining data you know. From that you have to find the other data. Okay. So this is very important problem in this unit. Before this end of the class, I want some students, I want all students to enroll in fundamentals of electrical engineering in the NPTEL course. So I want all students to enroll in NPTEL course. So I will show the procedure how to enroll. So if you already know that, you enroll and send me the proof. If it doesn't know, I will show you how to enroll. Okay. Go to the, I am removing, whether you have finished the problem. So after finishing the problem, I will inform you. So how to go to NPTEL website and enroll for the courses. I want everyone to enroll for the NPTEL course. You have to do the assignment. Those who are very familiar with the subject, good in subject, can return the exam. Okay? But everyone should enroll and do the assignment. So have we completed this? We completed, you put in the chat box. Now it is visible. So in the last class, the problem is in the camera, not in the classroom. The problem is in the camera, that next class camera is not good. Here also some blur is there due to the lighting. I should switch off the lighting. Have we completed the problem? Today 1, 2, 3, 4, 5, 6, 7, 9, 20 members. Out of 20 members, 4, 5, we are 5, 15, 2 letter entries, 2 are absent. Where gone Aswath? He is there, but now he is not there. Now we completed the problem means put completed in the chat box. So always the problem will be given in words. So you should first take the values from the problem and you write it in the symbol in the form of given data. So after writing all the values, you go for the formula and substitute. Then only it will be easy. For not for the subject, for any subject, you do this procedure. Okay. This is a good practice to write the given data and write the formula. Even though if you made mistake in the substituting, they will put some marks, step marks for the given data and the formula you have used. You get some marks. Okay, I will see the NPTEL course registration in the afternoon. Okay. So afternoon class we completed. Okay. Whether the screen is visible, SWAYAM website.
Yes, the screen is now visible.
Okay. So all of the students go to the website swayam.government.in. Government means gov.in. Then go to the sign in.register. So if you have no account, you sign up now. You go to the sign up. So you have to create a username, you have to create a password, and you have to give a mail name, email address. The verification, send verification code means the verification code will send to your email address. Okay. So then you can create a login. So after creating a login, so you go to the once again sign in. So I have already an account. So I will go through this Google itself. So after creating the account, you go through the sign in. So I am signing in through Google. Okay. Otherwise you can sign in using username and password. So either method you can do. So I am signing. I have forgotten the password. So I sign in using Google. Okay. Get into the put a verification. So I am moving into my login. So this is my login. So I go to the courses. So this is, I have enrolled in the courses so far. So you have to check this. So you have to, our subject is fundamentals of electrical engineering. Fundamentals of electrical engineering. Fundamentals of fundamentals of electrical. So after typing this, you click this box. So our subject will be displayed. It's not displayed. Why? Electrical. So it will work in Internet Explorer, I think. So I will send a video to your group. Time is up. So I will send a video how to enroll in NPTEL courses. Okay. We see in the afternoon. We see in DC machine some problems.